Welcome to video lesson 10.2 on the product of powers property. There are three properties you're going to learn here that help you to simplify expressions with exponents. One is the power or the product of powers property. Another is the power of a power property, and the product or the power of a product property. Sorry. A lot of very similar names, but they mean different things. So the product of powers property means that if you are multiplying powers that have the same base, so they have to have the same base, then all you do is you add the exponents. So for example, 4 squared times 4 to the third, they both have a base of 4. We'll just add the exponents 2 and 3 to get 5, and that's how we get 4 to the 5th power. Or in algebraic terms, a to the m times a to the n, the base is a, and to get the new exponent, we just add m plus n. Now the power of a power property states that to find the power of a power, you have to multiply the exponent. So if we have a base number raised to a power and then raised to a power again, that will really be, in this case, 4 to the 6th power times 3, which would be 4 to the 18th power. Okay. Now, the power of a product property helps us to find the power of a product, find the power of each factor, and then multiply. So kind of like using the distributive property, basically. So we're going to do, I'd have to multiply by that, sorry. 3 times 2 to the 5th power would be 3 to the 5th power and 2 to the 5th power. So we're distributing through that exponent to each of the factors inside. And then we would simplify that at the end. And in algebraic terms, ab to the m power would be a to the m power times a to the n power. M power, I mean, sorry. This should still be an m. Typo there. That should be an m, which is hard to read, not an n. Sorry about that. Alright, so now let's do a couple examples of powers with the same base, so using the product of powers property. Okay, so our base here is 2, and so then we're going to add the exponents 4 plus 5, and then we can simplify that to 2 to the 9th power. Okay, now here, what is the exponent of negative 5 when there isn't an exponent there? Well, that would be 1. So this is really negative 5 to the exponents 1 plus 6, so negative 5 to the 7. All right. And now we have our base of x, and the exponents are 3 and 7, so that'll be x to the 10th power. All right. Now example 2 is dealing with the power of a power. So here, when we have one base raised to a power to another power, we have to multiply the exponents. So this will really be 3 to the 4 times 3, or 3 to the 12th power in simplest forms. Now this would be w to the 5 times 4, which would be w to the 20th. Okay. And example 3, finding the power of a product. Here's where we're kind of going to distribute through that exponent to each of the factors inside the parentheses. So this would really be 2 to the 3rd times x to the 3rd, which we can simplify. 2 to the 3rd power equals 8 times x to the 3rd. Okay, and that's in simplest form. Now we have 3 terms inside this parentheses that we have to distribute the squared to. Then we can evaluate. 3 squared is 9, so we have 9x squared, y squared. And that's as simplified as we can make that expression. All right. Now we have a real-life problem to go through. A gigabyte of computer storage is 2 to the 30th bytes. The details of a computer are shown. Okay, and it says how many bytes of total storage does the computer have? So free space is 16 gigabytes. Total space is 64 gigabytes. Okay, that's a little blurry and hard to see. Sorry about that. So what we need to do first, okay, we know that there's 64 gigabytes of total storage space. So how can we write 64 with a base of 2? 2 to the what power will equal 64? Okay. Well, that's 2 to the 6th power, because 2 times 2 times 2, 6 times, equals 64. Okay, now we're going to use the information they gave us. So the total number of bytes, okay, equals the number of bytes in a gigabyte sorry, not gigabytes, times the number of gigabytes that we have total. Okay? Number of gigabytes. Abbreviate that. So, we don't know the total number of bytes yet. Okay? The number of bytes in a gigabyte is 2 to the 30th, because that's what it told us up here in the problem. And the number of gigabytes that we have is 64, which is 2 to the 6th. Now we have the same bases, so we just add the exponents, which would be 2 to the 36th. Okay? And we can keep our answer like that. So that's how many bytes we have. 2 to the 36 bytes. All right. Now you have 6 practice problems. The first 2 deal with product of powers, then it's power of powers, and then it is power of a product. Okay, so use those 3 equations to help you. Please write down any questions you have, and I'll be happy to answer them at the next class. Thank you. Have a great day.